Okay, guys, we're going to talk about section 4.1, and this is going to be talking about inverse functions, what we're doing here. So, if we have a function, okay, then the inverse of this okay, where all we're doing is we're switching the x and the y in each pair of stuff, okay? Now then, what we want to have, okay, we can always make inverses happen. That's not a concern, okay? What we really want to have happen, though, is that this is also a function, okay? In order to ensure that this is also a function, okay, we've got to make sure that f is what's called 1-to-1, okay? And so here is what 1-to-1 means. Okay, now we're looking for 1-to-1 function. Now, first part of that is function. We know that means x's don't repeat. Okay, the 1-to-1 part says that your y's don't repeat. Okay, because the idea here is that if the y's don't repeat, when you switch your x's and y's, the y's turn into x's, and since they don't repeat, that now creates the inverse is also going to be a function. Now, the other thing, okay, the way to prove 1-to-1 or show that something is 1-to-1, okay, is if A doesn't equal B, then f of A can't equal f of B. Now, the way we actually show this, okay, is we do the opposite. We're going to go if f of A does equal f of B, then that must mean A equals B, okay? And if we can show this, then we've shown that it is 1-to-1. So let's talk about how to do this. Okay, if I have a function, f of A is going to look like negative 4A plus 12. F of B is going to be negative 4B plus 12. And we're going to say if those two things are equal to each other, okay, that we need to show that A has to equal B. So subtract 12. We got negative 4A equals negative 4B. If I divide by negative 4, I get A equals B. This is 1-to-1. Okay, because we got that A equals B. Now you may be asking, then how do I know when something is or isn't? Okay, so let's take a look at another function. Okay, so f of A f of B okay, I'm going to set them equal to each other. Okay, now first thing that I'm going to do, I'm going to square on both sides. So it's going to get 25 minus A squared equals 25 minus B squared. Okay, now I'm going to try and get A by itself. So I'm going to subtract 25 off of both sides. I'll divide by negative 1. Now, at this point, I need to take square root on both sides. But guys, we have talked about when we take square root, we have to take plus and minus. Okay, now the square root of b squared is b. But the problem here is I've got a equals b and or a can equal negative b. This is not 1-to-1. Okay? That does not give us that it is 1-to-1. Now, the other thing that we can do, okay, and so this was an algebraic way to show that something is or is not 1-to-1. And again, the whole thing about 1-to-1 is that it's going to give us a inverse function. Okay, again, we can do inverses all day long. Okay, it just doesn't always mean that it's going to be a function. Okay, now, for example, with that last one, that square root of 25 minus x squared. Guys, that's a semicircle. Okay, and so one of the things that they will talk about is what's called a horizontal line test. Okay. Okay, so we've got a horizontal line test. Now, horizontal line test works the same way as a vertical line test. Okay, it works on the regard of that if it touches twice on a horizontal line, it fails. Now, what this says is if it passes, meaning it only touches in one spot, then inverse function. Okay, meaning that inverse will also be a function. If it fails, okay, inverse is not a function. Okay, so it's not whether or not there's an inverse. There's always going to be an inverse. Okay, it's whether or not it's going to be a function also as well. Okay, so taking a look at a couple of examples. Okay, they ask whether or not this graph is 1-to-1. Okay, remember that 1-to-1 says we're going to have an inverse function or that our y's do not repeat. 1-to-1 also means that it passes a horizontal line test. This one is not 1-to-1. Okay, because it fails in several locations, but that namely being one of them, it fails our horizontal line test. Okay, this one is 1-to-1. Okay, it passes a horizontal line test. So now then, the next thing that we are going to look at, okay, is creating inverse functions. Okay, so now one of the ways that we do inverse functions, okay, is it's basically called verifying inverses. Okay, and basically what this is they're going to give us two functions, an f of x and a g of x, and we're going to check and see which one allows us to, if we have what happens. Okay, so if f composed with g of x equals x, meaning when I do my composition, I get x, plain x, not x squared, not 2x, not 5x plus 7, okay? Plain x. And g composed with f of x equals x, okay? Then g of x is the inverse of f of x, okay? Now, with this, okay, what we have to show, okay, is that this works. Now, if it does not work, like if we go to do f of g of x, if that does not work, then it's over with, okay? Because it says I have to have both of these things happen. And if the first one doesn't work, then it's not going to work on the other one, okay? So the question, the example that we're going to look at, okay? So we're going to do f composed with g of x, that is f of g of x. I'm going to replace the g of x on the inside. Okay. And then I'm going to put this in. Now, because this cube root is over all of this, cube and cube root are going to cancel each other out. That's going to leave me x plus 1 minus 1, which is x. Okay, so that's a good first step. Now, just because it works the first time does not automatically mean it's going to work the second time. So you do need to go ahead and check the other direction. Give me the cube root of x cubed minus 1 plus 1. The minus 1 plus 1 will cancel off. Cube root and cube are going to go away. Okay. Now then, that means because I got plane x and plane x, they are inverses, okay, of each other specifically. Now, notationally, what we're going to do here is we are now going to say the inverse, and that does not mean a negative exponent, okay? That is the notation for inverse is going to be that g of x function, okay? What this does is, name-wise within the math world, this strengthens the relationship between these two functions, okay? Now, let me show you an example of one where it doesn't work, okay? So that you can kind of see where this process is going to kind of fall apart. Okay, so we're going to do f of g of x. Give me f of x over 2 plus 7. It's going to be 2x over 2 plus 7 minus 7. When we distribute the 2, we're going to get x plus 14 minus 7. That's going to be x plus 7. This is not going to work out because I don't, that plus 7 is extra, and you are not allowed to have extras when we do this. Okay? Okay. Now then, the other way, okay, that you can do is called finding an inverse. Okay, and this is a 4-step process. Okay, so the first thing is change f of x to y. Second thing is you're going to switch x and y. You're going to solve for y, and then you're going to rename y to f inverse of x. Okay, so I'll bring this down a little bit, keeping all that up there. And we're going to look at f of x equals 2x plus 5. Okay, so step 1 was change it to a y. Step 2 was switch them. Step 3 is going to be where we're going to start to solve. So I'm going to subtract my 5 back over to the other side, and I'll divide by 2. Now then, you really don't have to worry, okay, about trying to get this into like x over 2 minus 5 over 2. You can leave it kind of locked together right there. And then we're going to rename this f inverse of x, and it's going to be x minus 5 over 2. So it's that whole equation piece that we had here, and then we just rename that with that x inverse. Okay, so let's take a look at another one. Okay, so we've got f of x equals, okay, again, first thing is change that to a y. Second step is switch them. Okay. Now we're going to start to solve. First thing is I need the cube to come off, so that's going to be cube root of x. Okay, now you do need to be careful when you start moving stuff around with this, okay? Because the cube root only applies to the x. So when I add that 2 over to the other side, okay, I need to make sure that it is not up underneath. This is a spot where you're going to have to be very, very careful about what's supposed to be under a root is under a root, and what is not supposed to be under a root is not under a root. Okay, so there is my inverse. Now, I am going to look at one that is a little bit more challenging, okay, just because you may encounter one of these, and I want you to be aware of how to do it, okay? So f of x equals 2x plus 3 over x minus 4. Same starter steps. Y equals 2x plus 3 over x minus 4. Switch. Now, what makes this one a little bit more challenging is the fact that we have 2 y's in it, and now we're going to have to work on solving. Okay. Now, this first step does not seem like it would do us a whole lot of good, but right now I've got all the y's locked up over here, but there's no way for me to combine them together. Okay. So I'm actually going to multiply that denominator back over here to the other side. Okay. So now I've got this. Now, the next thing I'm going to do is, right now, still the only way that I can move y's around is to divide things around, okay? So we're actually going to distribute, okay? And now I can get my y's on one side and my numbering things on the other. I'm going to bring the 2y this way and move the 4x that way. So I'm going to subtract my 2y, and I'm going to add my 4x over to the other side. Okay, I'm going to bring this up here. Then I'm going to factor that y out. This is kind of a common trick that we see done in math, is when we have multiple letters, we try to get all the letters to the same side, and then we'll just factor it out. Now I'm going to divide the x minus 2 off. Okay, so now notice I have y by itself with the rest of this. So now my inverse is going to be 4x plus 3 over x minus 2. Okay, so there's our inverse for that one. Okay. Now, another thing that we need to talk about, okay, is graphing inverses. Okay, so with graphing inverses, you've got a couple of options. Okay, first option is switch x and y in your ordered pairs. Okay, so if you've got a bunch of ordered pairs, you can switch them all. The second option, okay, is when you do that, it is going to reflect over the line y equals x. Okay, now for some students, this reflection is kind of hard to see. Okay, but it's there. Okay, so I'm going to show you a couple of them. Okay, just so that you can see a couple of these examples moving around. Okay, so first off, okay, I'm just going to pick a line. Let's see. So this is the point 1, 2. We'll do let's see, we'll do over 1, up 1. So this is 2, 3, which means I'm going to have this point, which is going to be 0, 1, and then I'll have another point down here that's going to be -1, 0. Okay, so here's our line. Okay, I'm kind of going with that. Now, inverses, if I switch them, this is now going to be the point 2, 1. Okay, this point is going to switch to 3, 2. Okay, and I'm going to have to get rid of a couple points here. So this is now 3, 2. This one is going to turn into 1, 0, which is going to be here. This one is going to turn into 0, -1, which is going to be here. It's going to kind of go like this. Okay. Now, what's a little difficult to see with this is that this actually is reflecting over the line y equals x. What's going to happen is this is going to kind of keep coming up and over. They're almost running parallel. In fact, they are running parallel because I picked a 1-to-1 or up 1 over 1 slope. So this is going to reflect directly underneath there. Okay. Let me look. Let's look at another one. Okay. I'm going to pick something that with a little bit larger gridding. Okay. So we've got 0, 0, 1, 1, and 2, 4. So this is the startup for the right-hand side of a parabola. Okay. Now, 0, 0 is going to reflect to 0, 0. 1, 1 is going to reflect to 1, 1. 2, 4 is going to turn into 4, 2. Now, it's still going to look like a parabola. Okay. This parabola just looks like it's sitting on its side. The line runs right through here. Okay. Now, one other spot, okay, that graphs, okay, or inverses were used was in coding, okay. If you came out of the Algebra 2 pre-AP class, we did a matrix coding project, okay. So, for example, if I was going to say, if I was going to use the letters A is 1, B is 2, C is 3, so on and so forth, okay? And if I was going to spell the word friend, okay, my letters would be 6, 18, 9, 5, 14, and 4, okay? Now, what would happen is at a basic level, they would come up with a function, okay? So something like 3x plus 1, and they would cipher this, okay? So what they would do is they would do 6 and plug it in. So 3 times 6 is 18, plus 1 is 19. So I would send the code 19, and then 3 times 18 is going to be 54, plus 1 is going to be 55. 3 times 9 is 27, so it's going to take that up to 28. 5 will be 15, plus 1 is 16. 14 is going to be 42, and 1 makes 43. And then 4 would be 12, plus 1 is 13. So this would be what was sent. Okay, so this is the code that would have been sent, is this 19, 55, 28, 16, 43, 13. Now, in order to decode this, okay, we would need to know what the inverse of this is, okay? So if we turn that into y equals 3x plus 1, switch them. We got x minus 1 equals 3y. X minus 1 over 3 equals y. There is our inverse function. So I would, on the other end of this, know that x minus 1 divided by 3 is my inverse. Okay, so then what I do, okay, if I receive the code, I'm going to plug in 19 into this. So 19 minus 1 is 18, divided by 3 is 6. 55 minus 1 is 54, divided by 3 is 18. 28 minus 1 is 27, divided by 3 is 9. Okay. 16 minus 1 is 15, divided by 3 is 5. 43 minus 1 is 42, divided by 3 is 14. 13 minus 1 is 12, divided by 3 is 4. And then I work backwards and I go 6 is the letter F, 18 is the letter R, and so it would come back and say friend, okay? So this is one of the ways that they would use, okay, coding is they would create an alphabet for stuff, okay? And they didn't always use A is 1 and B is 2. They would do different alphabet numberings. And then they would code the message, send it in so it just looks like this garbled set of numbers. And then you would have to have somebody on the other side that knew how to undo the code to get it back out, okay? So hopefully you will be able to process now through your section 4.1.